Good morning. How's everybody doing? Okay, we're back. I think we're on episode 7. Let me know if you guys can hear me okay. Audio good. So this is a series of streams where I'm building a game from scratch and making the source code available for anybody for free, and that's over on GitHub. There's a link down below in the Twitch channel, and also all these videos are posted on YouTube, so you can go back and watch old videos if you want to kind of see the decision making that went behind all the code that's in there. All the art is also made on stream. I'm definitely a programmer first and foremost, and I can do a little bit of art, but this game isn't gonna look super good, but it's gonna be passable. So my goal with all this stuff is just kind of show how a game comes together and answer any questions people have, and kind of address some of the pitfalls and mistakes that people often make when they're putting a game together. So, passable is my middle name. Okay, so last time we spent quite a bit of time on resolution management, which is kind of a big deal, and that trips a lot of games up. So that's covered. We have an escape button that you can use to get out. We have this charge attack that has a cooldown, and we made a little interface element down here. So if I hit Q, then I'll do this kind of charge attack, and there's a cooldown on it. So ideally, we're going to get some more abilities down there, some more things for the character to do. And then we moved the charge attack from a mouse click to a hotkey, and we made this kind of mouse click ping thing. But you'll notice that when I click, it literally just makes a ping, and nothing happens. Like, I can't target these plants. If I click, my character doesn't run there, any of that stuff. So we still have quite a bit of work to do before we have, much of anything in terms of legitimate game mechanics. But that's okay, because we're just kind of playing it by ear, and we're just filling things out as we go. And as long as we are moving forward and making progress, then it doesn't really matter. So one of the things I wanted to cover this time around is input management, and how you might do something like get controller support into your game in an easily manageable way. And how to kind of code up your movement for your character and your inputs in such a way that you don't end up duplicating a lot of work. So I wanted to start there, and then once we have that, then we can start taking a look at putting some bad stuff in the game, maybe a way for the player to take damage or, lose. The way that I always like to think about it is that, you don't really have a fully functional game until the player has goals and then some kind of a toolkit that they can use to achieve those goals and possibly fail at achieving those goals. So right now, all I can do is run around. I have no purpose. My life is an empty void. I just juke around over tongue flowers, and everything is meaningless. So we don't really have a game yet. But camera zoom and pan. We may not get to that this time, but I'll see where we get to. Let me add that to the list. Okay. So let's take a look at inputs. And also, guys, let me know if the code is too small or if the text is too small on the screen. I can blow that up. Okay, so we're going to make a persistent object, which is just going to be called oInput. It's going to be our input manager. And we're also going to make, well, let's do a separate folder for this. Inputs folder. For scripts, init inputs. So for the player character, we have just a few inputs here, which is our WASD. So notice that these are just directly tied to hard-coded keyboard keys. We go into the step event, and we'll see once again the charge attack is just in the step event. It's just looking for whether I press Q on the keyboard. So this is not very flexible. And if we wanted to add a controller button or something like that, then if we kept this way, then we would need to, say like or controller button pressed. And then now, if we ever wanted to allow the player to rebind keys or change how this works, then now we'd have to go track down all the individual places where we have inputs and then manually change all of those things. So that's not very flexible, and it's going to cause us problems later. So instead, what we're going to do is we're going to have this object, which is called oInput. And this is going to listen for a variety of different inputs, button presses, stuff like that. And we're going to, essentially, the way to think about it is we're going to funnel multiple inputs into the same system, and then we're going to read from that system instead of reading directly from the inputs. So like, let's say I press spacebar to jump, right? So the input manager is going to say, hey, jump was pressed, whatever that means, because maybe it was an A on a controller, maybe it was a space bar, maybe it was a click, whatever. The input manager is just going to say jump key got pressed, and then the player will just listen for that. So the player will say, if the jump key was pressed, then I will jump. So it's essentially the idea is we're just funneling things together in one centralized location. So in inputs, we have 5 inputs at the moment. We have walk up, walk down, walk left, walk right. And we also have dash attack, I think we're calling it. And those are the only things that we can do right now. So I'm going to make enum. And we'll call this walk down. Let's do walk. Let's do it in clockwise 0 to 360 order. So walk right is 0, up is 90. Walk left is 180. Down is 270. Okay. So we have our inputs laid out. And we're now going to create an array, input info, and this will be where we kind of store information with the input. We'll give it a name just so we can easily reference it in debug code. And we're doing a little bit of setup here, and this will make a little bit more sense as it comes together. So I'm going to give each input a name. I'm going to give it a controller key and keyboard key. Although that's already we'll just do controller and keyboard. Okay. Keyboard. Oops, input info. So now I can attach multiple different inputs here, or multiple different I guess like control sources to the same action. So let's actually call this an input action. Okay. And the controller button, we will say pad R, and we will give this a name. So by giving it a name, this also allows us to display that name somewhere else, like in a key bindings page. Okay, and let's see, name, and then we'll call this walk right. Okay, so rather than needing to redo this with every single input, we will make a little script that allows us to do that. So we'll give it the ID, the name, the keyboard key, and the controller. Swap all these out. Keyboard, controller. And if we wanted to, we could also say, like, do something like this, where we store the defaults so we can later easily swap out the values, like this. So that way we can always allow people to restore the default key bindings. Okay, and now we can steal this, turn this into helpers, keyboard key, controller button. We can also have our input manager listen for joysticks as well. Okay, so that's good. That allows us to initialize things. So input setup, walk right, or we could just say right, I guess, or whatever. Okay. Keyboard key and controller button. GP pad R. GP pad is it's a built-in sort of constant that is for the different buttons on a gamepad. In GameMaker, a controller is called a gamepad because controller is oftentimes used elsewhere in code to refer to something that controls something else. So walk up, walk left, walk down. WAS, pad CL, and pad D. Okay, and then we'll get our dash action, dash, and we have this set up as Q. And we can put this as face 1, I guess, which is your A button on your Xbox. I think it goes like 1, 2, 3, 4, something like that. There's documentation. So, all right, so we have our inputs, and then in our init inputs script, this is where we can also create the input object, because none of this stuff works without the input object. So, you know, it's probably good to just have that. All right. So is that making sense so far? This idea that we're gonna create the concept of an input action, and then we're gonna listen to a bunch of different things, and then act like sort of read from the input action, not directly from the inputs. Okay, and let's also do input state. All right. So none, pressed, held, released. Oops. So typically when you're handling inputs, there's sort of like four possibilities here. One is nothing is happening. Pressed means that the input has literally just been pressed right now. Like this frame is when the key was initially pressed. Held means we've got the key down, but it was pressed some time ago initially, and it's just now being held down. And released means that this frame, we are not holding the key, but we were holding it last frame. So we'll create our own input states here. Okay. Now under O input, in the step event, actually let's go to the begin step event so that we can read inputs before anything else happens. Hold on, I'm kind of off center here. All right. Okay, so let's see. So we have our input keyboard, controller, blah, blah. And we should also state equals that. All right, so we're just going to iterate through all the inputs, read whether or not anything is going on with those, and update their states accordingly. So, so let's go ahead and just grab this for reference, and we can put in a comment here. So the input ID is I. Probably, instead of just using a letter, let's make this more clear. All right, so then we'll just say if keyboard check pressed inputs input I or this input and we want okay, so you kind of see what we're doing here. We're just swapping things out. And actually, we could probably, maybe to make this a little bit more clear, bar. Input states. Yeah, let's do this. Okay. And let's replace this inputs with input info so that this is just a 2D array that stores information about those inputs, just static information. Okay, yeah, that's a little better. This input, okay, if we press the keyboard key, then we will set the state to pressed. And let's just set it to none at the outset. Now if the keyboard is held, oops, then we set it to held, and if it's released, okay, so I'm going to clear this out. Okay, and this is a persistent object, which means we spawn it right at the beginning, and then it's just there, just doing its thing. Okay, and then we want to What I like to do here is just make some easy scripts so that I don't need to like remember the names of the array that I'm using and stuff. So input pressed is a script where we can ask. So it's a script where we can just ask whether an input was pressed. Right? So instead of having to remember to ask this question all the time, I can just run the script input pressed. And then same thing here, which is just input held. And this one is released. And that's it. So now in the player object, instead of this keyboard inputs thing, we could even say like walk inputs. And that's going to be input action dot walk right. Walk up, walk left, walk down. Okay. Originally, we were only thinking about these as keyboard inputs. So let's find where that is. So now we're looking at walk inputs. So instead of saying if keyboard check blah blah blah, we're going to say if input held. Okay. So you see we're kind of like, we're now, instead of listening directly to the keyboard, we are now just checking what's going on inside this global array. And the input object is now listening to the keyboard, and it's updating that array. So the cool thing here then is in the input object, we can now do whatever we want in here. We can have this listen for joysticks. We can have this listen for mouse clicks. We can have this listen for controller buttons, any of that stuff. So let's run this first and see if this is working as intended. We only hooked this up to the player's movement. So, okay, so I'm pressing WASD, and it's all good. It's all working. So, that's step one. And then in the player, we also want to update. We also want to update this Q button. So here, instead of if keyboard check pressed, we'd say if input pressed. That. Would you ever have your controller actually perform the action on the player? Meaning, like, would I code up the code for like listening to controller inputs here in the player object? Is that what you mean? All right, so my dash attack is working. All right, so I'm going to commit this. Okay, and this is, we now have a centralized input manager. rather than having the O player listen, just have the O input have a with. No, because we want to keep all of the code that is specific to one thing as close to that thing as possible. Because if we have like O input, so here in the player object, we have like, you know, if I press the dash button, then do all of these things. If I move that to the input, then now all of a sudden, some of what the player is doing is in this, and some of what the player is doing is in the player object. So that is sort of like a classic road to spaghetti code town, which is now all of a sudden you don't have things compartmentalized, and if you want to modify what the player is doing, you can't open up the player object and figure that out, because something else is now sort of like puppeting the player. So there's a book called Clean Code, which I highly recommend. It's a pretty easy read actually, but it's basically talks about a lot of the principles of keeping things compartmentalized and modular, and trying to keep those sorts of things from happening. So this input object should only read and update inputs. That's all it will do, and it's now up to the job. It's up to like a player object or something else to read from it, and then they will decide what they're going to do with that information. Okay, so the next thing we want to do is get our controller inputs working. So this input object is a great place to do that. So, because again, it handles inputs. So if we want this to be a single player game, then like with no same screen co-op or anything, then we can just make a single global variable, which is just says like, current gamepad. Okay, and so a gamepad has slots. So when I have like let's say I have 4 Xbox controllers hooked up, one of them is in slot 0, one of them is in slot 1, one's in slot 2, one's in slot 3. Weirdly, if you hook up a PlayStation controllers always start in, I believe, slot 4. So if you're thinking, oh, I'm going to read from the first 4 inputs, you're never going to actually get the signal from a PlayStation controller for some reason. So people have a lot of weird workarounds for those. But for most controllers that are meant to be used with a PC, you can just read from slots 0 through 4. So the problem there is like you want to make sure that you aren't. It's expensive to read from these. So meaning like if you want to take inputs from 16 controllers at a time, then you have to iterate over 16 controllers and lots of different inputs, and it kind of hogs your CPU. So you don't want to just like spam it. So what we'll do here is in our input object, in our step, we'll make a region which is this. So this is where we're going to figure out whether or not there's a controller that we should be listening to. And we'll only do this if we aren't already listening to a gamepad. The unfortunate part about spaghetti code is that many organizations say speed is productivity. You end up with software that's riddled with bugs, and you end up wasting more time than you realize. Yeah. Was that the you cut a corner, you make 2 more corners. That's if you take home nothing else about programming, that is the lesson. So let's equals. I think there's something about gamepad is connected. Okay, let's just read the first 5 slots. That way we'll catch that PlayStation controller. And also if we don't already have a gamepad, then we'll keep going. Most millennials don't get this point. All they want is quick and agile movement. Well, I mean, it's not a generational thing so much as an experiential thing. Once you've built a huge project out of spaghetti code, that's the only time when you really get to appreciate just how terrible it is. Because in the moment you're moving really fast, and as you're building things, you can implement any feature in 5 minutes, right? And it works. But then once you start releasing it and patching it, and you have to sort of run live ops on it and maintain it and continually expand it, then you end up in this scenario where every new feature you add becomes dramatically harder, because it has to integrate with systems that weren't built to scale, right? So, but it's I think, as with many things, having people tell you that that's important, especially as a young person, and you're kind of in the early stage of that Dunning-Kruger thing where you know a bit about programming and you feel like you know everything about it. And so when you have people telling you to take your time, write test cases, refactor your code, compartmentalize your functions, all that stuff, then you end up with a scenario where you think yeah, but look at the results I'm getting. I'm making stuff super fast, and these old folks don't know what they're talking about. In a previous podcast, you mentioned using MVC. What would that mean in the context of this game? Oh, that's an interesting one. So MVC is the model view control approach. So in this game, this would basically mean we would kind of abstract away a lot of the mechanics, and you see this this player object, for example, doing all these different things. What we would actually probably do is we would separate out the visuals of the player from the mechanics, and we would have basically something that renders all of the different things happening onto the screen. Something that actually is the mechanical code, and then something that controls all of that stuff. So we kind of talked about that in the context of level head when we were working on dynamic spawning and despawning, where a lot of what you would see in the game, the objects themselves are actually doing nothing. They are just showing you a picture of something that's happening, and all the stuff that's happening is actually happening sort of somewhere else. So the MVC model is useful. Model view controller model is useful for certain things, depending on your aims, but it's kind of complicated. So I like sticking with just keeping things more contained, like what we're currently doing here. All right, so if you don't have a current gamepad, we're going to iterate through all the different slots, and then we're going to say, for starters, we'll say a GP slot, gamepad slot. If gamepad is connected, so the question here is what do we want to do here? How do we want to assign a gamepad? Because one option is we could just say, you know what? If we just detect a gamepad, then we'll just treat that as the gamepad. This is kind of a common way to do it, but this creates a lot of confusion on the player side, because if you've got 4 gamepads hooked up to your computer or something, and the game just picks one of them and uses that, and it doesn't use the others, then now the player won't know which one to use, and it's going to seem like it's broken, right? So what you want to do is instead just wait and do nothing until you actually get some kind of input from the player. And that's the point where you assign the gamepad. Any reason why you don't put parentheses around your if conditions? Yeah, GameMaker doesn't need them. So I do it if there's like multi-part if statements typically with with ands and ors and lots of logic. But if I'm just asking a single question, then it just doesn't matter. All right, so if Gamepad is connected, then what are we going to do? We're going to listen to different inputs. So we have all these different Gamepad functions here. So let's see. So Gamepad button check pressed. So we could just listen for like a start, which would be like this button. We can also listen for tons of stuff. So we can listen for a whole bunch of different buttons. Like any of the face buttons. We could listen for D-pad buttons. I think there's actually, is there any key? No. Gamepad. Yeah, so for keyboard, you actually have this nice, like, any key thing. On Gamepad, for some reason, we don't have that. I don't know why. Pad L. What other buttons we want to look for? We could look for the shoulder buttons. LR, LB, RB. Let's get select in there. We're just really... Okay. Just ors for days here. Alright, so that should do it. Oh yeah, and this is why we line things up. There we go. Good morning. Iron Crusader 99. Yeah, you would think GP any would exist. Let me look again just to make sure. No. Nope, 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 nope. Maybe there's a function. Gamepad. Nope. Okay. King Javo, I've been programming in GameMaker like 40 to 80 hours a week for a decade. So, took a long time to get here. All right, gamepad slot. What are we doing here? Okay. All right, so then we assign the gamepad, and let's also listen for joysticks. Let's see, gamepad axis value. And actually, let's do absolute value. So the joystick axes come back as a -1 to +1. So you have like your left horizontal axis, your left vertical axis, your right horizontal axis, and your right vertical axis. So all we're asking here is have any of the joysticks been moved beyond like the halfway mark? Okay, so got our axes here. You know, we can just go ahead and roll those into the same if statement. That's fine. Seahawk. I'm a little bit sick today, so that kind of helps with the voice. Get a good microphone and a cold. That's how you do radio. Okay, so what do we want to do here? So we want to kind of debug this, right? So let's make sure this is working. We can actually do one of the things I like to do if I want to just like really throw something out there in my face for debugging is just say show message, because that just freezes the game and throws a big message up on screen. Just do this. Okay, so we're just listening for tons of controller inputs here and then setting a gamepad. All right. I'm gonna move a joystick. Okay, so we got gamepad connected. I don't know if you guys can read that; it's pretty tiny, but gamepad 0 is connected. So phase 1 is good. We've got our input here. We can stop showing this message. Okay, so here we're saying find an active controller. That's our current job. Now we also need to figure out what to do to deactivate a controller. So so we can just do an else here. Move this in here. Okay. All right, so we're gonna find an active controller. And if we have an active controller, then we need to know whether to disable it. So if not, gamepad is connected. Current gamepad. Then we just reset back to -1. And then we could do something here where we could say like, actually we don't need to iterate there, but if the gamepad is connected, then we could, you know, for example, like look for a start button press or something and then just deactivate that gamepad if we wanted. But use the async load event at all to detect controllers. You do have to use that on Nintendo Switch. The weird thing about all that stuff is it's looking for controller connections, and it's a little bit less. My only worry with those kinds of things is that if you're on a console like a Nintendo Switch, like yes, people are just using the controller, and that's just it, right? Like there's no keyboard or any other way to control the game. But with PC games, people typically have multiple control types hooked up to the game simultaneously, or even like multiple controllers, but they only plan on using one. And so I find it's pretty useful in this case to just look at what the player's doing. So if the player starts using the keyboard, then just start listening to the keyboard. If they start using a controller, then just start listening to that specific controller. But yeah, I have used the async stuff for controller detection. Not a lot, but a little bit. And man, the Nintendo Switch programming stuff is crazy for controllers because you can take a controller and you can then like break it in half and now treat it as two different controllers and then like change modes, and so you have to code up all these different ways of listening for controllers. Yeah, so there's no reason to have it as a setting if you can just listen for things. So, all right, so now that we're listening for the gamepad here, and we can pick one up. Then now down here in our input manager, so here we will say keyboard inputs, gamepad inputs. Yeah, man, take that out of your... I mean, we do have in Levelhead, we have a setting to treat the controller and the keyboard as two separate players, and that's a toggle. Well, not gamepad is connected if current gamepad isn't set. If current gamepad is -1, then gamepad is connected will just return false. So, but this is an else, so current gamepad is -1, then we're listening. If it's not -1, then we are checking whether it's still connected. Alright, so we have our gamepad inputs down here. I'm going to tab this in just to make it a little more readable. Alright, so then we'll just do the same thing. If gamepad button check pressed dot controller and we are going to listen for current gamepad. So what we have to do in Levelhead is actually we have 4 input channels because we have an input channel for every player. And so when gamepads are used, the order in which we pick up the gamepads, we assign them to different player slots. And then, so this input states in Levelhead is actually a 2D array. So it would be like player ID, that. So this system is very expandable by just into same screen co-op. You just need to listen for more gamepads. Okay, so then we check, are we holding this input? And last, button check released. It's weird that they have like gamepad button check pressed, released, and then just check. I don't know why this doesn't say held. Okay, check released. That. If we want to make this a little bit cleaner too, we could say do this. Kind of feels weird having those 2D arrays in there like that. So you also notice this does not currently handle joysticks. This is only buttons. So we'll have to get that as well. We thought of making a sports title. If we did, we would probably make up the sport. Okay, so we have our controller inputs. Let's see what happens here. Okay, so I'm pressing A. But notice, like, where am I charging to? I'm charging to this finger location, which is a little bit... Alright, so we have kind of like a confused control scheme here. So we'll have to figure that out. And if I use the D-pad buttons, it's all working. I don't know if you guys can see that. I press A. And then on the flip side, I can just immediately start using controller, and it takes all the inputs. So this was kind of a struggle when we were working on Crashlands because the game was built to use mouse movement and single click. So because we didn't plan for it, and again, like there's a reason why I'm covering controller inputs and stuff early, is because we didn't plan for it in Crashlands. And it took us 300 hours to rebuild all the systems to be able to accommodate keyboard and controller movement. Which, if you're doing the math, that's like 8 weeks of 40 hours a week. So, you know, it's better to have that early. Because all the interfaces needed to be rebuilt. All the game systems needed to be rebuilt. So, okay. So we're listening for this. And then last, let's take our joystick stuff. So joystick is a little bit odd, but let's, because it's a whole other thing. Like, it's not a button press, so you can't really use your it's just like it's just these values that just kind of float around from -1 to 1. So let's see, go to our first. Let's get our dead zone. So first you want to, we'll call it joystick dead zone. So you always need a dead zone on your joystick. It's an axis. Yeah, so a dead zone is basically, no joystick ever sits exactly at 0. They have a small amount of drift, and some of them will even go up to like, 10% of the way in some certain direction. And that's gonna basically give you ghost inputs on your movement. So you always have this dead zone that you want where you just don't listen to any inputs within a certain distance from the center. So we're going to give ourselves a 20% dead zone, which is fine. And we can even, I got a sick dog back here. This whole household's falling apart. Set axis dead zone. Okay. So we can do this in the input, which is once we grab our gamepad, then we can quickly give it its dead zone. Device. Let's do that. Okay. So that's going to give it that 20% dead zone, so we're just not going to read any inputs inside of there. Joystick, let's see. How do we want to handle the joysticks? I guess for now, because we only have one controller, we could put it in the player. No, we need to have a separate global variable for this because there's a possibility that we would end up with on-screen joystick, which needs to then map into the same thing that a controller joystick does. So we'll say joystick LV, which is left vertical. And so if we wanted to make these into like a multiplayer thing, then we could also do, for each player, you'd turn this into an array. So for each player, you just give them a separate joystick. Okay. Get even. Actually, for my own sanity, I'm going to call this X and Y. And we're going to get rid of this LH. All right, let's see what I'm doing here. All right, joystick X, joystick Y is zeros. And joysticks 0, equals okay, that's fine. Okay, so we are going to use our input to listen to joysticks. So if we have a gamepad connected, we're going to say 0 is left stick and 1 is the right stick. I'll just initialize that here, actually. So that we have one variable that's an array that stores all the information we need. Virtual joystick. We could do that if you guys want to see it. Once you get this all coded up, then it becomes pretty straightforward to do a virtual joystick. Okay, joystick X. And we can even do length 1D. Just in case we add more joysticks. Okay, so we are resetting the axis for joystick X and Y. Let's get out of there. Okay, so if our gamepad is connected, then we can listen for these values. Okay. So we're going to reset those values, and then we will say stick equals GP axis LH. So the reason I'm using X and Y here is because this whole like HV nonsense is weirdly confusing for me. Like, I get it's horizontal and vertical, but if you're programming the whole time you're using X and Y, you know, it just gets weird. Okay. So we have those, and we should be able to, let's see, we should be able to have the player, I don't know why I did it this way. This was quite a fumble. There we go. Okay, so let's just go in the draw GUI event, and let's just draw these out because I want to see these values. Joystick X, joystick Y. Okay. So remember we have our font set. We'll do our header font. Middle. Okay. So we'll just draw the values of the joystick axes so we can see what's going on with these. Draw text. We're going to draw this at GUI width. I guess we'll say GUI center X. I don't know, 200 is fine, whatever. Times I. I'm just hard coding this in because I'm going to delete this in a minute. I just want to see it. Minus 50. 100, whatever. So I should do a regular font for this. Okay. The string is going to be joystick X, I, scale 1, white, that. And then below that, we will draw the Y. And let's see what this gives us. Okay, so now got my controller. Okay, so it goes 1 to -1, and if I go up, it goes -1. If I go down, it's 1. So that maps onto GameMaker's Y up is negative, Y down is positive. And then right joystick, we've got all of our values. Okay, so you can see that there's something kind of interesting that happens here, which is like all the way right is 1. And if I start going down at an angle, you notice that right stays 1 for a while and vertical stays 0. There's like a little bit, I don't know if you can see me wiggling this. I'm going to get real close to the camera. So as I wiggle it, it sticks. Okay. So most gamepads have a built-in axis lock, where basically there's like a 5-degree window around the 4 main axes, where it just locks you to that value, which is kind of interesting. It makes it easier to do game, because like if you had to be perfect when going exactly up or exactly to the right or whatever, you couldn't really do it. And so actually most controllers just lock you into those for a little while, and you have to kind of like go outside of them. And the other thing you notice is that as you go to like a 45-degree angle or something like that, you have this weird thing where it's like 45 degrees, you end up with like 3/4 of the way to each axis. Right, because this is a circle, so the numbers kind of work out oddly. So how you interpret joystick inputs can actually be kind of complicated. But in the case of the player character, what we're going to end up doing is we're just going to use these joystick inputs to get a direction, and then we're going to just walk in that direction. So I'm going to leave that debug stuff on screen for now. So in the player object, we're now going to start listening for those. So in the step event, let's go down here. So we have movement input X, movement input Y, and we are using those to get this movement direction. Okay. So before we take our walk inputs, we are going to take joystick inputs. So we can even just say joystick X and joystick Y, and we'll say zero. Yeah, how does developing for the Switch work? Yeah, you do need a dev kit, which is a common thing for developing for consoles. So if you're working with Sony or Microsoft or anybody who has a console, you'll need to get your hands on a dev kit, and they'll handle it differently. So sometimes maybe they'll send you one, sometimes you have to buy them or whatever. And there will typically be some kind of software that you would use to sideload your game onto the device for testing and stuff like that. They'll oftentimes have like developer dashboards so that you can get access to certain testing things. And then you'll just, for Game Maker, it's pretty much just like, you click up here and you just choose your targets that you're going to export to. And then it's just kind of taking the time to debug any weirdness with compatibility problems or control scheme problems or something like that. Yeah, so the Switch was definitely pretty hard because of the controllers. So like getting it actually up and running was very easy, but updating all the control schemes to handle the single Joy-Cons, because they only have one joystick and they're missing a bunch of buttons, that kind of thing. And so all of a sudden, all of these interfaces that we built with the intention of having two joysticks and all these other things, all of a sudden you just don't have that anymore. So, okay, so let's see if this movement code works. So I'm not going to use my joystick. See? And so now we have joystick, we have D-pad, and WASD. So we're just like taking all these inputs at once, and the player experience is super great for this because they don't have to do anything. They just like pick up whatever they have and just start doing things, and the game just does it. So, and I'm gonna leave those joystick inputs on screen so that we can do a virtual joystick. So I'm going to push this. How do you handle more than one player? Great question. One sec. We have controller support now. All right. So if you were going to do more than one player, so we have this input states map, right? Right now, input states is a one-dimensional array. So it's just every input has an entry in the input states map, and that's that. If we wanted to have multiple players, then we would end up making this a 2D array. So we would say like less than however many players we want. Do that. And then we would do this. So we would say if we have 4 players, then we now create 4 slots for handling inputs. And then we iterate over all those different things. So and we would also keep a list of active gamepads for any given player, and we would assign gamepads to people as they come, and then update the states using this 2D array. So the nice thing is, because we've done this in our OInput object here that just handles everything centrally, then you could also in your player, you would give each player a player ID, which is essentially like I'm my player 1, I'm my player 2, player 0 would be the first player. And then that player object would then be like joystick X, that. Like, let me just look at my own player ID of my own joystick. So, which we could add same screen co-op to this if we wanted. Could probably do that in this stream. We gotta get our virtual joystick first. Yeah, let's do that. All right. Virtual joystick. All right, so we're going to give this virtual joystick a radius of like 400. Sounds like a lot. This is a 1080p screen, which means that's going to be 40% of the screen, which means on a phone, going to be like this big, which is actually quite small. So the hard thing about developing for mobile is that you're developing it on a giant screen and everything looks enormous. And then as soon as you just switch over to a phone, it's microscopic and you can barely see it. So, all right, virtual joystick, radius 400. We'll just have this thing position itself for now. So we'll put this at radius is 20. Just hard coding this for now. GUI bottom. Okay, and we're just going to have this thing draw itself. So draw draw circle. XY radius. We make it more faint than that. My dog roaming around back there. Okay. Okay, so we've got our virtual joystick. We can have our gameplay interface spawn that, I suppose. Joystick. Okay. So let's just hit play and just spawn this thing first and just take a look at it. See, just visually get a sense. Okay. All right. Radius 400. Should have been 200. That's a diameter of 800. That's too big. So, okay. Redo. This is why we test. Okay. That's a lot better. So here's our virtual joystick. We want to probably, this thing is a, do we have the interface item? Interface element. All right, this thing is an interface element. What's in here? Width, height. So by making this thing a child of the interface elements, it gives us the ability to coherent. So remember with this ability icon thing here. So it gives us the ability to query whether the mouse is sitting on top of an interface element, or whether we're actually clicking in the world and stuff. So always good to have your interface elements be children of some kind of cohesive interface concept. Okay, so we have our radius, and then we want to also draw in the center of this thing. We will draw the sort of like the place that we are clicking. So this little dot in the middle is going to move with our mouse. Okay. So let's do X plus joystick X 0. Let's say var. What do we want to call this thing? This is like a joystick visualizer. X. Also, I'm going to be stumbling around a lot here because I have totally not made a virtual joystick in quite a long time. So, come on a journey with me. You a 28-week-old husky? Oh man, that's a lot of energy. My dog is some kind of a random smattering of things. Nobody's been able to figure out what she is. She's 40 pounds, kind of tannish, but has some kind of like weird spot-ish things. She's kind of got a lean build like a whippet. Okay, so now you can see I'm using the joystick here. Okay, so now you can see it. but we want to read from it, right? So, and also this gives you a good visual of how it snaps. So vertically, if I'm over here in the corners, you can see every small movement gets red. You can see how it just moves little bits, right? If I go all the way over, and then notice how like I'm wiggling the joystick a little bit here, and it's not moving at all. And then only once I go far enough away, then it starts moving. So there's actually like what is happening, like the numbers that come into your game are a lie. There's a lot of forgiveness mechanics that come from these. So okay, so we want to be able to click on this dang thing and read from it. So let's do that next. So the question is, how should we do this, right? Because we want to compartmentalize things. So probably our input object should just look for the joystick, the virtual joystick. Okay, so that way all of our inputs are handled in one place. And this is kind of like the MVC thing, right? Where like this virtual joystick might not actually be the joystick. In terms of like what is reading the inputs, the input object would be the thing that's doing that. So that's one possibility. Another is the virtual joystick will read the inputs, and then the input object will take those and turn them into something. So it's basically as if the virtual joystick is just another gamepad. So let's do it that way. All right, so in the step event of the virtual joystick, we are going to say, let's see. Touch device is -1. Okay. I don't think we've talked about multi-touch yet. So let's do that. So multi-touch on a phone or an iPad or whatever. The reference here is that every finger that touches the screen is like an additional mouse. It's like an extra device. And so you can iterate over them like this. You can say like, oh, I want to read like up to 5 inputs or something. Okay, so you can then say like, if this device has its left mouse button being pressed, which literally just means that the screen is being touched, then we can check for whether or not that position is in range. So, and for being concise, so we convert that to GUI positions, and then we'll say if point distance okay, so creating and destroying it when lifting your finger. Well, you don't want to. Well, I mean, you could do that. I would instead of creating and destroy it, you can just make it visible or invisible. One thing I like to do is actually have it be always visible, but then grow in response to what you're doing. So, okay. So now we can say point is less than radius. Press equals true. So we can stop listening for other device inputs once we get one. Joystick X, joystick Y equals dx minus x. So in other words, like where is this in relation to the center? dy minus y over radius. Okay, so I think that would work. So in here, I'm going to now say, so the reason I'm dividing by radius is so that I can convert it to something between 0 and 1. Okay, so now as I click on this thing, then it should move. Okay, so a couple things you notice. One is when I click, I'm summoning pings because I'm clicking through it into the world. So let's stop that from happening. With a cursor here, we're spawning the world ping. Let's make a interface function, which is interface item at pos, or interface element. Safe area. If you put your finger within that area, the joystick starts out at that position. Yeah, I've seen that one a lot. Your best bet with touch controls is to make them flexible so that people can pick control schemes that they want, because pretty much all touch controls come down to the player becoming accustomed to very specific like positions of things, because you can't feel anything. So you have to just kind of like learn where your thumb goes. And some people like the joystick that floats around. Some people like a joystick that's in a specific place. The downside of the joystick that spawns when you press is that you can no longer instantly do things. You always have to drag, because wherever you click, you're now always in the dead zone, and then you have to move from there, right? So you like tap, then move, tap, then move. A static joystick means once you know where it is, you can just tap to the side and you're already moving on the first tap. So I'm running the script, which will allow us to ask whether or not an interface element is, or which interface element is at a certain position. So we can use that to decide, like, if I clicked somewhere, did I click on something on the interface or not? So plus width plus height. So one thing here is this is not taking into account depth. So I'd like to do that as well. So let's say closest depth. So what we're going to do here is, it's like, what if we have several interface elements that are overlapping? Like you've got a button that's on top of a map or something like that. We always want to return the interface element that's closest to the screen. So we want to depth sort that. So, okay. Okay, so if this interface element is at that position, then the last thing we do is just check the depth. So there we go. We now have our get the interface element at a position script. So now in our cursor, we want to, so we're checking if the mouse has been pressed. And if it has, then we will say we will get where we're at on the interface. Okay. So if we did not get an interface element at that position, we will spawn a world ping. So let's try that. Ooh, no pings. And then if I click outside, there's a ping. Once I go like right in there, there it is. So then same thing, I click on this, no pings, because that's a child of the interface element. And I click right outside of it, and now I'm back in action. So this one actually has a rectangular mask, because it was made before we had the radius concept. So notice if I get outside into the corner, then there's no ping. Then I gotta go out a little ways. So that's fine, whatever. No one will notice, except that I just brought attention to it. But other than that, don't worry about it. All right, so we have our virtual joystick. We now have our joystick X. Okay, so what else? Well, for starters, we need to reset our joystick every frame, right? Because when I released, then all of a sudden it would just stay there, and now I'm just perpetually running that direction, which is silly, right? So now we have this, which is nice, right? But this kind of feels a little aggressive, like it's just teleporting around, and that's no good. So let's also give ourselves some visuals. We're gonna lerp this. Oops. Pretty fast. Okay. So this is just gonna give that smooth movement, right? We can lerp it a lot faster than that. Okay, so that's starting to feel better. I do want to also draw a central circle in the joystick so that we have like a sense of where the middle is once you start moving the joystick. So you just gotta play around with this and like give it a sense of you're doing stuff. Okay, so something else that I like to do with joysticks. So there's one note here is like, watch this. I click here, I'm dragging, and it's gone. That's not good because people will just drag their thumb right off of that joystick. So we don't really want people to just lose control of their movement because they dragged slightly too far, right? So, so what we will do here is we have our touch device variable. We will say if touch device is -1, meaning we don't have a record of anything being touched on the screen yet. Then we're gonna listen for for whoever's like whatever finger is touching the joystick, and once we get that finger, then we're gonna just say, guess what? That finger is now our joystick finger or thumb, whatever. And even if it comes off of the joystick, we're still just gonna listen to it. So, okay, so let's say touch device equals D. And then we just clamp it. Okay. So, see if that -1, 1. And we also need to check if we're no longer holding it, then we unassign the touch device. All right. Whoops, we missed something. D. It's not D. It's touch device. Okay. Don't know how that didn't crash though. Okay. Right, is this right? Touch device. Yeah. Your dog loves blueberries? That's pretty dope. Alright, so now I click out here and I'm dragging, and now we've got this kind of weird problem, which is like, look at this. I clamped it, but I clamped it in a rectangle. Right? So what we really need to do is figure out the direction. Right? Because now, like, if I'm dragging out here, I should actually be kind of like higher up, which is a little bit odd. So, okay. Joystick dir equals point direction x, y, dx, dy. Okay. So instead of this clamp, we want to say joystick distance min 1 dx dy divided by radius. Well, first let's not do the min. Let's just get the distance here. And we'll say joystick x is now going to be length dir x joystick dist joystick dir. So we've converted this. Instead of just looking at exact x and y coordinates, we're now getting a direction and a distance, and flipping that back around. So notice, like, I clicked on it and now it's like going way out here, which that feels dumb and wrong. So what we're going to do is we want to kind of cap it so that it hits the edge and then stays there. So all we do here is we just we say we can't go past 1 as a distance from the center. So now we get the direction correctly, and it doesn't go outside. Okay, so that's part 1. Now the character needs to actually listen to the joystick. And another nice thing to do is have it respond more visibly when the player touches it. So we'll start at a scale of like 0.7. And if our touch device, if we are actually using the thing, then we scale up the joystick, and let's see, and then we'll scale it back down if we aren't using it, and then we'll only use that visually for the outer ring. So basically what this will allow us to do is, like, when you touch the joystick, then it does something responsive. So it feels cool. It feels like it's listening to you. It's taking your commands. This is something we noticed in Quadrupus Rampage. So Quadrupus Rampage and Talfight 2, the Monocle of Destiny, use the exact same code for character movement, and the same code for their virtual joysticks and everything. Talfight 2, when we launched, got a lot of people complained about the virtual joystick in Talfight 2. And when we launched Quadrupus Rampage, we got a far more praise about how tight the controls were. And under the hood, both games actually used exactly the same virtual joystick and exactly the same character movement code. The one difference was that in Quadrupus Rampage, the joystick did this. That's it. It just scaled up when you touched it. So, for some reason, the fact that it responds immediately to your touch and seems like it just feels better. And so, even though what's actually happening in the game and what you're doing with your thumb are exactly the same between the two games, one game gets applauded for its controls and the other gets panned. So don't underestimate the power of juice and responsiveness on the things that you're putting in here. So, okay, so we have our virtual joystick. Now we just have to have it be read by our input object. Yeah, don't underestimate blinking. Make it juicy. What's up, Tiny Big Games? Tiny Big Games. Like it. All right, so here we are in our input object. Now we're going to read from our virtual joystick. We're going to use a with statement so that if we just don't spawn the virtual joystick, then nothing happens. So, all right, so we'll say joy dist and joy direction. What's up? Just doing this, streaming, making a game. Okay, so we have our joystick distance and direction. This is where the dead zone comes in. If the joy distance is greater than the joystick dead zone, see, it all comes back. We'll say greater than, yeah. Then we say joystick x 0 equals that and that. Okay. Since the player is already reading from that global variable, then now, oh, so, all right, so this is a problem because remember, we are not resetting it here, right? Joystick, if it's greater than the dead zone, we're using it, and otherwise we're not. And we are never resetting the joystick values. And we're only doing that if there's a gamepad. So that means we should take this here, this reset, and get it out of the gamepad specific code. Put it up here. So now just every frame, we're going to reset the joystick X and Y. Based on Steam experience, I have tips on what makes a game rank. How many wish lists do you feel you need to make an impact on search? I don't know. I mean, we've had a hard time getting visibility for Levelhead on Steam so far, but we don't know if that's just an early access thing, because we know that a lot of lists and algorithms just chop out early access games entirely. There's also a big velocity thing. Like if a lot of people are coming into your game from outside of Steam, then that seems to beef you up in the rankings a lot. I think the title of the game matters. I think everything matters. I wouldn't say any one thing is important by itself necessarily. It's the whole package. Because, I mean, you can do everything right and still end up getting just no traction. And everything right, meaning you've made a game that gets a great response, gets great reviews, gets covered by press and YouTubers and stuff like that, and still just it may not get any uptake. It's hard to predict. All right, so virtual joystick working. Okay. Good stuff. So notice this is not using any kind of analogs. Like as soon as I'm out here, I'm just running full speed. So we could update the joystick to use analog controls where it kind of like listens to incremental values. We don't have to worry about that for now. Yeah, Steam SEO is tricky. Definitely make sure that you have your game's genre set and your tags set. We actually had Levelhead sitting in, in a coming soon state for, say, like 8 months or something, and we didn't have all of our tags set up. And then for like the first 5 months, 6 months, once we put the tags on, all of a sudden we had like 6 times the traffic to our store page through the discovery queue and stuff like that. So we actually just like missed thousands or tens of thousands of people seeing our game for that time because we just missed a single checkbox, So it just take the time to go through all of the stuff on the Steam backend and try to think of all the ways that any of those can help your game. Okay, so now I have WASD. I have virtual joystick. I have controller. There we go. And all these inputs can be handled simultaneously. They all get funneled through the O input object, and they all get read by the player. So one thing to note is that if you pull this code down and you bring it to a mobile device, then you'd just be able to boot it up and start using this joystick. Except you have to press space to play. So probably one last thing is update that so that it listens to other things. So, I'll just leave this commented for anybody who wants to use it. I'm going to push this. Virtual joystick. Are the tags in the dashboard? Yeah, it's all in the dashboard. Multiple players and camera zoom. I could probably get multiple controllers. Yes. I can get multiple players, and then we could maybe do like a Smash Bros. Style camera next time that zooms and pans around. Okay. But we want to get multiple players. Let me get this other controller. Alright, so we want to get multiple player characters in the same game. Hey, Junker, how's it going? Alright, first thing we're going to do. Every player gets player ID. Player ID is basically just like what slot they are in. So, yeah. Have the camera zoom out and in as players move to the board. Yeah, that's like a Smash Bros. Style camera, where as people get farther apart, the view expands to accommodate, which isn't too hard to do actually. So we got 15 minutes. We can add multiplayer and Smash Bros. Camera. NBD, no big deal. Okay. So, am I streaming tomorrow for Labor Day? No, I'm celebrating Labor Day by hanging out, recording a podcast. That's it. All right. So first, we want to say we're gonna allow up to 4. We're gonna allow up to 8 players playing this. Oh, you're in Hurricane? Oh my god. It's crazy. Joystick X. Alright, so basically we just turn all these things into 2-dimensional arrays, where we start with the player ID and then the thing that we're talking about. So here, input states, player, input ID. Array, P less than max pairs. Okay, so we are going to now listen to various gamepads for all these different players, etc., etc. Instead of current gamepad, because now we can have lots of different gamepads. What am I going to do when they take 2D arrays out? Refactor all of my code. Alright. But I mean, a 2D array will just be, would just be this. Like, it's not going to be specifically complicated to update. Just tedious. Okay, so we have our joystick. What are we doing here? We need, so current gamepad. So basically every player needs to have a gamepad ID, right? So current gamepad is going to be 0. And instead, we are going to, we could even do this, flip this around. Current gamepad, P equals -1. Okay. We'll spit coffee on your keyboard. That's the worst way to clean a keyboard that I've ever heard. Okay. So now we're iterating through. If this player doesn't have a gamepad, now we also need a list of active gamepads, right? We need to know. We don't want to be checking a gamepad that is already in use, right? So this is I'm doing this kind of fast, so this is gonna be a little bit less coherent. Active gamepads list. Okay, and current gamepad active. I think this will work. All right. The keyboard will be energized. Stop sticking. I don't know if it stops sticking. Might. It's worth a shot. This in C#. This is GML. This is Game Maker language. It's got its own thing going on. I guess people say it's close to JavaScript. Vaguely. But also in many ways, not at all. So, okay. We're iterating over the players. So if the player doesn't have a gamepad, then we will check. So for starters, if this gamepad is connected, do we have this DS list contains? Is that a function we've made? Not. Oh, this is my favorite function. If you're checking for something in a list, DSList find index will return -1 if it's not there. But rather than doing this every time, just ask DSList contains. It's much more straightforward. Active gamepads. Element is GP slot. Okay, so we're not gonna do anything with gamepads that are already in use. Okay, we're only gonna listen for ones that are not. Current gamepad P equals gamepad slot. Okay. All right. And if my gamepad is not connected, then I reset this thing to -1. And I'm going to add another one. DSList delete element. Okay, let's see. Decided to stop work on all levels until Rebound is released. Huge gaps that you have no idea what to do with. You could just jump over them. I mean, that's what the game is about. Return DSList find index. Okay, so what we're going to do is we're going to make DSList delete element, which is going to delete a thing from a list. So we could iterate over the list. And every instance we find, don't worry about that. Just delete that slot. Okay, so this just allows us to delete specific things out of a list by identifying them. And I have to do this before I reset it. Oops, took a screenshot. That didn't need to happen. I've got ShareX hotkeyed to control down. Okay. Current gamepad. Gotta do this. Joystick X. Okay, so you see how we're just converting everything into an array here. Iron Crusader subscribed. Very nice. Thank you. Looks like my overlay isn't doing its job here. Oh yeah, ShareX is incredible. Okay, so we're gonna say that the virtual joystick is just is just going to be player 0, because presumably we aren't going to have same screen co-op with a virtual joystick. That's weird. Some people want that, you know, maybe we'll do a split screen where, like, you're on an iPad and you're each holding one end of the iPad, you know. And you've got your half of the screen, and you flip it upside down and they've got their half, and it's like two, I don't know. That would be dumb, but also kind of awesome. Okay, so we have this. I'm going to do a quick search for current gamepad just to double check and see. Okay. Oh yeah, so now for the inputs here, we need to also iterate over the player IDs. P less than max players. Okay, input states P, this input. Okay, so for starters, we only want to take keyword inputs for player 0. So, you know, there's that. Done. And for gamepad inputs, we're going to do whatever we want. So, this gamepad is that. And if this gamepad actually exists, then we do that. Okay. So I think it's a good way to sort things by type. Which levels in Levelhead have a certain tag? Okay, so my joystick is working here. If I use my other gamepad, nothing happens because we don't have that concept. As a player, I should just make sure that the player is... Oh yeah, we also need our input pressed, so... Oops. Now we have player ID. Input states that. Okay, input held. Boom, boom. Input released. That. Pressed, released, held. Input held. So I'm now tying the player's player ID to our input code here. And here we have input pressed, which should be player ID. Okay, let's check that that works for player 0, because player by default is 0. Okay, so our WSD works, our D-pad works, our joystick works, virtual joystick works. Okay. So the last thing to do is to spawn an extra player character. Yeah, they're removing 2D arrays so that you can have 3D, 4D, 5D arrays. That's basically it. Because right now GameMaker is limited to only 1D or 2D arrays. Okay. Now we need multiple players. We'll have our gameplay controller check for this. So probably, I don't know, just in the step event we can do that. So we're going to say in the gameplay controller, we will check to see if we have the wrong number of players. It's less than. I guess we could just look for how many gamepads we have. So max 1, reduce list size, active gamepads. And we'll say non-players. Yeah, this will work for now. Okay, player instance. This isn't going to work later, because if the player dies and the instance goes away, then this is going to break everything. That's okay. I know this, so we'll cross that bridge when we get there. Instance number of player is less than num. Okay, so we're missing some player instances, and now we are going to spawn them. So we need player IDs required, and we need to figure out what IDs to assign to the new player characters. So we're going to add the IDs required to a list, and then with every player instance, they'll just remove their own ID from the list. And then what we have left is a list of IDs that need to be spawned. So instance create 0, 0. We'll just say it's already, yeah. Player ID equals player ID is required I. And then we delete this whole thing, clean it up. I'm good. So presumably this will spawn players as we connect more gamepads. Okay, so I'm running around, then I start jiggling the other gamepad. Oh, there it is. Looks like we are both controlling the same one though. So we gotta fix that. Current gamepad. Ah, here we go. I missed some array conversions here. Input states. Okay. Let's see if that works. Running around. Okay, so my joysticks aren't going because I'm probably misreading those. Yep. Not even reading it right. little bit of debug, you know. Running around, other character running around, do. Oh my god, we now have chaotic multiplayer. Let's grab another gamepad, see what happens. Me and the boys. All right. Got another gamepad hooked up. There we go. Okay, so I'm really straddling a lot of controllers here, you know. Okay, so it's all working. So if I want to add more players or fewer players, in inputs, I just change this number now. So, hey, it's a 4-player game now. Hey, it's an 8-player game. Hey, it's a 16. I don't know how many controllers can you hook up. That's how many players there are. Git commit. Just, you know, there's multiplayer now. Real Mr. Ward. Yeah, how's it going? Yeah, you definitely want to have a message pop up when somebody joins the game. All right, so we are past time, but I think I can get the camera zoom in without too much issue. So here's what we need. Instance target. No one. Wrong. Instance target is now a list. Okay. Camera set target. DS list add. Instance targets. We'll do that. And we also will make something called DS list add unique. So there's just a little script that says, hey, if this is already in the list, don't add it in there again. Why no Mac or Linux build? The Mac version of GameMaker has had broken web functions for like 6 months. So that is fixed now. And we have an early build of that we are working on. Linux mostly because Linux just kind of loses money. If you don't have a hugely successful game, then the population pool of Linux users is going to be like, no matter what, it's going to be like, I don't know, maybe less than 1% or 0.1% of your overall user base. And it costs money to take time to test builds and deploy them because it takes we have to do that, right? And so it's just a cost benefit question. If you have too few people in a market and it costs you the same amount of money to deploy to that market, then at a certain threshold you just lose money. How much overhead is it? Well, we have QA testers that we have on staff, and we have to test the builds. We do have automatic build pipeline, but it's more of we have to pay people to test things. So We could just click export and send it out. But that's, you know, not a good business practice. Got to test things. And then fix them when they break, which they will. We did actually have some, I was going back and forth with somebody who was getting level head running under Wine in Linux, which was apparently working pretty well. Well, one of the issues with putting the game out to players is if something goes wrong with the web functions. So one of the things that was happening with Mac was when you would try to export, like upload a level, we would get a confirmation like, yep, everything went just fine, but GameMaker was actually stripping out all of the binary contents of the level. So you would successfully upload a broken level. And so then other people would start to go try to play stuff, and then they couldn't actually load the level because every level you uploaded was corrupted. And also, you would take all the time to build that level, and when you would upload it, it just gets deleted, basically. So there's a lot of kind of like serious repercussions for a web-based game for us to put broken builds out, you know, because it can actually ruin the game experience for all the other players. Yeah, so, you know, if it's a single-player game, I think I would definitely agree with you on that, which is like, yeah, you know, just make a beta branch, put it out there, make it known that it's unstable, and people can play at their own risk, and that's fine, but we have to make sure that we don't put everybody's play experience at risk in an online game. All right, so we have our instance target. So what we're going to do with this camera is we're going to give the camera multiple instance targets, and then we're going to try to do this like Smash Bros. Camera thing. So yeah, one thing that makes me sad about the Linux stuff is like I love the Linux community because the Linux community is just like a bunch of total nerds in like the best way, and they love fixing things and like tracking down problems and like figuring out why things aren't working. And so they're just like the best customers to have because anytime something goes wrong, they're just like, oh, interesting. And then they just go, like, that's a new fun thing for them. Whereas you're more like mainstream users, if something goes wrong with the game, they're just kind of mad about it, which, you know, everybody's got their thing. Yeah, I just wish that the Linux player base was big enough that we could justify putting that much time into it at this point. Instance targets. All right, so I'm gonna just update this. Okay, so what we got to do here is we need to figure out of all the instance targets, just like where are they in terms of left and right bounds, and then we just drop the camera right in the middle of them. So I need to be part of the solution. I cannot create markets. I mean, ask all of the game developers who made thousands of VR games to have no players appear with VR headsets. You know, as a developer, I go where the players are. I can't make new pools of players. They're just already there for me to, you know, maybe Valve needs to fix this problem, or Microsoft, or, you know, somebody needs to make that market, and then I'll make entertainment products for it. Okay. So what we're going to do here is we're going to iterate over our list of instances, and we are going to find the left and right bounds. So x left equals min x left Man, if I had the power to just like manifest a new market, I wouldn't have to sell things on Steam. That's for sure. I will say, you know, if once we fully launch Levelhead, if we reach a point where it just does have an extravagant number of users, then like there is a point where if we got like a 1% increase in desktop users by opening up Linux, you know, if the like the cash income from that 1% is high enough, then of course it's worth it. But you know, 1% of 10,000 users is very different than 1% of a million users, right? So I actually think that this is something that, you know, AAA developers need to be pushing because, of course, like they move far higher numbers of units. And a lot of them do use Unity and Unreal Engine and stuff like that these days. So I'm going to say max. Okay. So now we're going to lerp toward x left, x right, y top, y bottom. So we're going to now go to the midpoint between the left and the right bound, and the midpoint between. Oh man, can you imagine the marketing department in real life? I'd have to like go play hundreds of Steam games in order to have people play my Steam game. Yeah. I mean, it is the case that like it's easy to just initially export a game to those platforms because of things like GameMaker, but those platforms are always changing, and the creators of the engine can't always keep up with all of the new issues, and so it'd be a case that, you know, even like with Crashlands, we have it on like 12 different things, and we have to maintain sort of like a grid of understanding like which GameMaker runtimes have which issues with which platforms, and so we have that all integrated into our deployment pipeline. So that we know like, oh, if we're building for this platform, we want to make sure we use this GameMaker runtime because of this one specific issue. It's just crazy. So isn't x left, x right the same? Same with y. No, yeah, it's min max. Okay. Instance targets. Let me just quickly make sure that okay, so camera set target. So this is now uniquely add. Okay. Instance targets. And in the gameplay controller, this is how we have this like create the camera, create the player instance, set the target, right? So every time we make a player, we're going to want to make it be targeted by the camera. So probably should just make a script that's just called, you know, spawn player that just does that. So whenever we spawn a player, we'll just put the camera on him. then here, get rid of this and spawn player. And actually, we should give them the ID. Spawn player, 0, 0, 0. Position 0, ID 0, 0, 0, 0, 0. And then we will update this. So here, instead of this instance create player, we will say spawn player at position 0, 0, ID that. All right, so let's test that out at first. So the camera now should drift between the two players. And I'm actually gonna have the camera draw just a dot or something. Min and max of x, same x will be the same value. No, you are missing something. Okay, so the camera now drifts between and to the midpoint. Dot. It's just my debug dot. Don't worry about it. I just dusted it off for a minute. Okay, so what we're doing with the camera here is we're doing a min and a max for every instance. So we're going to pass this in and we'll basically say like, hey, if this target's X is farther left than the last target, then we'll keep moving over. And if this target's X is further to the right than the last time, then we'll keep moving to the right. So, yep, so we just take whichever one's further left, whichever one's further right, whichever one's higher up, whichever one's further down, and then we lerp to the midpoint. All right. So there's that, and then the last thing is this view size thing. So I haven't done this since they changed the camera stuff, but I think we can manage it. Camera set view size is a thing. So the question is, how big should this be? New var, and how do we do it in a way that's not jarring, right? Equals, say view width, say curve view height, because we also don't want to do this in a weird way. So essentially we need to just like figure out what the zoom of the camera needs to be, and then do that. So let's actually say base view width (1920, 1080), and actually that's not true. It's the GUI size. So the nice thing about the user interface is it never changes size, so you can just use that as a baseline. And the problems you deal with zooming is distorted pixels. Yep. Pixel art. Technically, if you're using true pixel art, you simply can't zoom. You know. I love games that are pixel art games that rotate things. And it's like you see the pixel, and then the pixel becomes a diamond. And you're like, I mean, I get it, but that's not a pixel anymore. That's a diamond made of smaller pixels. Current view size, view, okay. So we want to figure out, maybe give a margin of 100 or something like that. And we want to get the current sort of like size from the left to the right, top to bottom. Equals height equals y top minus y bottom, or no, other way. Okay, and then we need to figure out the zoom. New view height is going to be max base view height minus, no, base view height, target height, plus edge margin. Okay, so we're gonna say like if they're 1,000 pixels top to bottom, then our new view height should be that plus a little bit extra. So, but if they're closer together than our base view height, then we just don't care. Now note, I'm calculating these things independently, which means if that's all I did, then I would end up with a weirdly squished screen. So I'll use zoom in scaled increments. So you'd be like powers of 2, something. A new view width, or base view width. New view zoom target is going to be, so now we need to kind of like standardize this across the two, across the height and the width. So whichever if height and width, whichever one zooms us out farther to a higher zoom factor, then we'll just take that zoom factor and then retroactively apply that to the existing view sizes. New view zoom target is going to be the max of new view height divided by base view height. So whichever one of those is bigger, that's our new zoom target. And then we could say new view height is actually base view height times new view zoom target. Okay. So right now I can just straight up set the view size. And we can try that and see. Just double check this. Yeah. Okay, trying to get farther apart here. We are getting the zoom, but because we only have that like 100 pixel thing, then it's pretty close to the edge, right? Like I can't see crap out there. So, and of course, 100 pixels gets smaller and smaller as we zoom, which is another thing, but that's okay. Yes. Ugh. Let me just come back with my spin move. Okay. Good morning, Kenny. So I'm going to need to beef up that edge margin. Let's try like 300. So we're still feels like we're, and it's going to be actually worse vertically because my character is a certain number of pixels tall. So there's that. Let's just straight up give it a 500. You didn't annoy me at all, King Java. That's the whole point of this thing. Okay, so the interesting thing about this is you can actually use the camera zoom as a means of encouraging or discouraging certain things, right? So like, if you set up the camera zoom such that as players, does it seem like, oh, okay, so edge margins, this would actually be 250 on either side. So, your daughter's gonna become a game dev? Cool. Or maybe. If she wants, you know. Alright, so oh yeah, what is it? Oh yeah, so the camera here, the camera can mechanically influence what players tend to do. So if the camera is really liberal about its zooming, and it's just like, yeah, as soon as you get out there, we'll just show you everything, then players can just kind of freely run around and not feel like their field of view is obstructed in any way. So if we zoomed out a lot more, then the players don't actually need to really stick together. If the zoom is just there to make sure that people can like mostly see, but if it's actually kind of like harder to see outside certain areas, then the players will stick together more because they can see more if they're closer together, sort of like immediately around themselves. So you can kind of play around with how your camera works and make that go. So I'm going to have this camera use a lerp. So we're going to set the camera size as a, let's see, our zoom lerp speed. We can do it pretty fast, that's fine. So we'll say lerp, curvy width, new view width. I think this will work. Or it will end up squishing things weirdly. Yeah, it's kind of like a fog of war sort of a thing. Are we going to get squishy? No, we're good. We're good. Okay, so this just makes it so that there's a bit of lerping that happens, even though the camera zoom is already based on player movement, which in and of itself is already sort of like a continuously changing value. I'm going to zoom back over. Cool. So, okay, so we got some camera zoom here. We got some camera finding the midpoint. Let me get rid of that dot. I know it's kind of triggering for some of you there. Let's get that out of there. Okay. I'm going to commit this. where are we here? Let's get rid of that. Next episode will be episode 8. We got controller support, so that's cool. We also added multiplayer, so that's nice. Camera zooming in and out and tracking multiple players. And I quickly explain lerp. Yeah, so lerp is way to think about it is it's just a way to close the gap from one thing to another using a percentage each time. So if I say, like let's say my x is 0, I'll just kind of type this out. So let's say my starting x is 0, and I'm saying like lerp or x equals lerp x 100 at 0.5. So what that means is in the first frame, I will be at 0. In the second frame, I'm going to be at 50 because I'm closing 50% of the distance every time. In frame 2, I'm trying to get to 100. I'm at 50, so now I'm going to be at 75 because I only had 50 to go. And in frame 3, my x is going to be 87.5. Frame 4, blah, blah, blah. So it's like it starts quickly and eases in. And so you can use this for most things. It gives things a little bit more like a more kind of organic feel to them. And I use that in the clamping lerp is good, right? It depends on what values you're using. Like if you wanted to, you could say you could figure out the distance you're going to travel and then make it so that it like doesn't go too fast, and you could kind of work with that as well. So okay, so I think so. I pushed that. All right. So next time we're gonna do yeah. Let's get some actual gameplay stuff in there. Let's get some enemies in there or something that harms the player, something to avoid or something to pick up. We got inventory to work on. We got all kinds of stuff to work on. So thank you guys for coming. And again, the code for this is available on GitHub. And you can just pull this down and just have it. And the reason I'm making this all from scratch is so that there's nothing proprietary in here. There's no like B-Scotch owned code that you have to worry about. You can just take it, put it in your projects, do whatever you want with it. So thank you guys for watching. I really appreciate you guys coming back here every week. It's very motivating for me and it's very helpful. So I will see you guys next time. Have a good week. Have a good Labor Day weekend too, for those of you who are doing that. All right, later.